Today we're going to look at adding and subtracting fractions with unlike denominators. Now remember, we cannot add or subtract fractions that are not in the same size pieces. It'd be like taking 3 inches and 5 feet and saying we had 8 feet or 8 inches. We can't put them together until they're the same size. So one of the big aspects will be finding a common denominator. We are going to use some of our old skills that we've already learned this year as we are going through and getting our final answer with these fractions. So let's start with this example 1. The Graff family ate 1 1/8 of pizza for dinner and a half more of the pizza for lunch the next day. About how much pizza did they eat altogether? So first we are going to identify what's happening in the story problem. So we're going to write down our expression to prove that we understand, is it adding, is it subtracting? And eventually we'll be multiplying and dividing later in the year. So our expression, we would be doing 1 1/8, and we are adding, because it's the more, we're adding that half for lunch that next day. And if we want to know altogether, we know we're doing that addition. So we're going to use our benchmark knowledge with estimating to the nearest benchmark with these fractions. So we look at 1 1/8. What would that equal as a benchmark? So what would this become? What nearest benchmark would it become? You should have said it is 1. So our nearest whole would be 1 or 2. And if we look at that 1/8, then we can see that it is closer to that whole. So now what about the half? What nearest benchmark would that be? The half would be to a half. That is a benchmark. So you're going to use that one as your estimate. Then we have a nice easy estimate to be able to see what our answer should be about. And that would be what when we add those together? It would be 1 1/2. And of course, wanting to understand what we're talking about, we are going to label this, and it is about 1 1/2 pizza. Okay? So now that we have our estimate, we can get to the actual answer. How much pizza did they actually eat in all? So first, what we are going to do is picture this problem and kind of look at those different pieces and the sizes. So here we have that 1 1/8 of pizza, and then showing if we had a half more. We can see these halves are not the same size. We can't just say it's 1 more with the 8s, and we can't just say the 8s go with the half if they're not in the same size. So the section needs to be divided into same size, equal parts to add. This also is true for subtraction. Use lines to divide the fractions into 8 parts. This works because 8 is a multiple of both 8 and 2. So seeing that we are working with 8 and 2, if we find that common multiple, we can then get them into same size pieces. So what they're saying is we could cut this into 8 and then be able to add those pieces together. Okay? So we are going to demonstrate that with the actual fractions. First, we are going to find a common denominator for each of these fractions that works for each of the original fractions, and then make the equivalent fraction so that we can then actually add, and that would be the calculating. And there's some things that we might need to consider along the way with that. So we have 1 1/8, and we have a half, and I like to line them up so I can show what they equaled for you. So our equivalent fraction is going to come into play next to it, but the equivalent fraction is all based off of that common multiple. A common multiple is the same thing as a common denominator for these two numbers. So what could 8 and 2 both become? What multiple do they have? Now, when we've talked about this, there's a lot of them. And so there's not just one answer, but there is the best one is always the smallest. So I'm going to encourage you to use this least common multiple or the smallest common denominator. Those mean the same thing, but those are the ones that do work too. So what would work for 8 and 2? you hopefully said 8, because 8 times 1 equals 8, and 2 times 4 equals 8. So I can have these both become an 8. And what I just mentioned is because 8 times 4 equals 8, and 8 times 1 equals 8. Now we know with equivalent fractions, if it's going to be equivalent, anything stays equivalent if we multiply it by 1. So right now, we're multiplying it by 4 and multiplying it by 1. We have to do the same thing to the numerator. And that's where we get that 1 whole in. So 1 times 1 is 1. And we also have to carry over that 1 whole. That's nothing different is happening with that. So we still have 1 and 1/8. This one didn't change because we use the same denominator. It's this one that now we are multiplying it by 4 as well, because we're following what the denominator did. And then our numerator, our equivalent fraction, is now 4. Once I have my common denominator, like we said, and I've made my equivalent fractions correctly, I can then add. So I'm going to take these two fractions and add them together from our story problem. I have 1 for my whole number, and then my numerators, so this is just like 4th grade, adding fractions with common denominators. So 1 plus 4 is 5, and then our denominator stays the same because we're still talking about 8s here, and our answer is 1 and 5/8. So for my solution, I have 1 and 5/8 of pizza. Now, the whole point of estimating was to make sure our answer is reasonable. So if we go back up to 1 1/2 being our estimate, if we look at 5/8, that is a half. So 1 1/2, our estimate is proving that our answer is reasonable. We can even look at our model and see that when we cut these into 8s, we had 1, 2, 3, 4. So there was 4 there that we could then add on to our 8s that we had from the 8s of the beginning amount. And then you can see you have 1 and 1, 2, 3, 4, 5 8s. So models can help visualize what's happening with the numbers, but we really want to get to the place where we are showing that common denominator, right? And getting equivalent fractions and then adding or subtracting, okay? So how does that differ when we get to questions like this? For example 2, Sarah is building a house and uses a board that is 4 1/6 feet long. She cuts off, kind of an important aspect there, she cuts off 2 3/4 feet. About how long is the board now? So what operation is going to be happening in the story problem? Should say subtraction. So I'm going to show that I understand that in my expression that I'm going to put 4 1/6. That's the start of the board. We're subtracting the 2 3/4 because that's how much is being cut off. Estimating again to make sure our answer is reasonable. If we look at our 4 1/6, what does this nearest benchmark, when we estimate this, what does this become? Looking at your 1/6, it would be closer to 4 wholes. Yeah. And then what about 2 3/4? What would 2 3/4 estimate to when you're looking at your benchmarks? 3/4 is going to make that round up, isn't it? So that's going to be a 3. A nice, easy calculation of 1 foot. Our board is approximately about 1 foot long, right? And now we're going to jump into actually calculating it using finding our common denominators, making equivalent fractions, and then calculating. So we have our original problem of 4 1/6, and we are taking away 2 3/4. Let's show us getting those equivalent fractions. One thing I want to make sure you remember is we are keeping these whole numbers intact to get those common denominators. So now we need to look at our 6 and we need to look at our 4 and go, okay, what is a common multiple of 6 and 4? Now again, there's more than one. What would be maybe even the smallest one? What should we use? What do you think? What could they both become? should have said 12. Did you say 24? Because 24 would work. 24 would work because 6 times 4 is 24. That is a common multiple. But our life is going to be so much easier if we use our smaller ones because we have to multiply to get to this number. The larger our multiple is, the more we're having to calculate, and we have bigger pieces. We can visualize and function with fractions more in the real world if they are simplified to the smallest terms that they could be. And if we're putting something into 24 pieces, that's harder to visualize than, say, 12. So our common denominator is going to be a 12. It became a 12 for the 4 because we multiplied by what? We multiplied by 3. So that's happening to the numerator as well, multiplying it by 3. I like to write this to show you this is how I'm getting my new equivalent fraction, that numerator, and how it's happening. You should have a 9. Now again, of course, we have 2 in 9 12, so don't forget that whole number's there. And then for our 6th becoming a 12, this was times a 2. So doing that to the numerator as well, you would have a 2 as your numerator. Now you should be noticing something pretty important here that we did come across when we were practicing our adding and subtracting fractions with common denominators. So we even practiced this before we had to get equivalent fractions. Do you see what's happening there? I left us some room so we can see. What issue are we going to run into? What are we going to have to do here before we can start fully getting our answer? We have to borrow. We can't take 9 away from 2. So remember, when we borrow from the whole, and this is going to become a 3. When we borrowed one whole, what are we going to add to the numerator? What is a whole even worth in this fraction? It's worth 12 twelfths. Yeah, one whole equals 12 twelfths. It's all based off of what makes this a whole, and in this case, 12ths. If we were looking at the original fraction, that is 6. 6 6, 4 fourths. All the fractions are based off of what makes a whole is their denominator. And so here, if we're working with 12ths, we need to borrow a whole. We are adding on 12. So if I add on that 12, I really have a 14 because I had my original 2 there as well. So 12 plus 2 is 14. Now I can subtract. So 3 minus 2 is 1. 14 minus 9. What would we get there? We would get a 5. And then denominator stays the same of 12. So with this story problem, what would our label be if we had 1 and 5 twelfths? So about how long? What would our label be, do you think? It wouldn't be long. How are we measuring these boards? We're using what? Feet. So we would have to say feet. I said foot up here because that's singular for 1. And then feet is more than 1. So we do have more than 1. We don't have 2 holes, but it is more than 1. Okay? Let's check our estimate. Are we about at 1 foot? Yeah, we are. We are about at 1 foot. This could even be considered about 1.5. But still a good estimate. Remember, estimate isn't precisely going to match our answer. It's giving us an approximate, okay? So here we had an extra element of not only having to get common denominators, and then equivalent fractions, but then we also had to borrow. We're going to see that here with our 5th grade fractions, okay? So let's do a few practice problems together. So I want you to jump into this one, and I'll guide you through. Even pause the video and see if you can get that common denominator and get the same equivalent fractions as me. Remember, I'm going to encourage you to use the smallest common denominator you can. And if you use a different one than me, it's possible our answers are going to look different, but they are equivalent. So we'll look at that and talk about that together. All right, so let's go ahead and look at 4 and 7 twelfths plus 5.5. Go ahead and pause and let's see how you do. All right, so let's check your answer. What did you get for your final answer for this problem? Interesting. I got 9 and 13 over 12. What kind of fraction is that? Looks a little off. It's an improper fraction. We can make this into a bigger mixed number. So before we even do that, check this out. Did you use a common denominator of 12? You could use 24. You could use lots of different options that 2 and 12 have in common. As a multiple, but 12 is the smallest one. So your numerator would stay the same. This whole fraction would stay the same because the denominator already is 12. And then for 5 1/2, it would become 5 and 6/12. So I added them together and I have an improper fraction because the numerator is larger than the denominator. That means I need to show how this became a bigger fraction. If I can take a whole out, that means I'm going to have 10. But then how much do I have left over? Anything? Well, if I take a 12 out of the 13, I have 1 left over, and we're still working with 12s. This is my final answer. How'd you do? All right, well, for number 2, it's a subtraction one. Go ahead and get your equivalent fractions, and let's see how you do. All right, I have my equivalent fractions. I use the denominator of 30. It is the smallest one, and it just so happens that 5 times 6 equals 30. So my numerator should be 24 over 30, and then I should have a 25 over 30. Make sure you're bringing over your whole numbers. And, ooh, we have it again. We need to borrow. All right. When you borrow from that whole, and this becomes a 9, how much are you going to add to the 24? What makes a whole here is a 30. So if I add 30 to this, it's going to become a 54. So 54, and then we are going to take away that 25. What would that equal? So you already are set up to, since you borrowed, if we take 54 and we subtract that 25, we would get 29 over 30. And then subtract the whole numbers, 3 and 29 30ths. That was a big one. Okay, you are going to do the next 2 completely on your own, and we'll compare answers. Go ahead and do number 3. What do you get? All right, how'd you do? The answer to number 3 is 3 and 14 over 21. So you should have used a common denominator of 21. Your numerators became 6 and 7, and you can add those together and get a 14. It is not improper. It's good to go just the way it is. All right, let's try number 4 now. This scenario looks familiar. We did practice this when we did common denominators. Let's see what you get. What is the answer to 12 minus 9 and 6/7? That one was actually easier because you don't have to get common denominators. You get to make it immediately. You can't take the 6/7 away from nothing. You have to borrow from the whole. So I made my whole become 11, and then I made a 7/7. Why did I pick 7/7? Because then the denominators are already the same, and then I can subtract. So my final answer is 2 and 1/7. Okay, you're going to get on that practice, and you are going to do lesson 10 and 11, practice 3, where you are getting those common denominators. Show me all your thinking, all your work on your paper. Make sure you're numbering and put your final answer on the line so I can tell what you intend for it to be checked as. And make sure your final answers are mixed numbers. So we're really working with all of these, just no story problems, just making numbers for today, going all the way to question 12, I believe. Let's see one more time. Yep, we are going to do 12 of these. So practicing those common denominators, okay? All right, I look forward to seeing your work.